Okay, guys, we are continuing here with the different types of modifications we can do to our exponential function. As I said, I prefer doing it like this rather than having this huge formula with a lot of letters and everything that you're going to be afraid of. So there's a case where I have a coefficient here, and it's when I have something like this. F of x equals going to be something like, it's going to look like this: a times b raised to the power of x. Okay, it's the same. This is the case. This is the case of the example here about the internet users worldwide. I have a number multiplying here. Actually, that's the most similar form to the general term of a geometric sequence. Okay, it's the same thing. It's like, this is like the original amount and then it grows. Actually, if we go back to that example, it was like 400 times 1.17 raised to the power of x. So now my initial value, well, not initial value, but my y-intercept, it's exactly here. It's at the point where it takes this value. Okay, so it's at y equals the value of this coefficient. Okay, but let's get rid of this example because it changes my graph too much. Okay, so what's important about this case? Okay, this, in this case, the most important thing I want you to take into account here, because you see, like, if I write different things here, it's just going to give me different things, a different y-intercept. Actually, I can complete this definition here. Instead of saying it has only one y-intercept, which is a bit obvious because that happens for every function, we could say something more specific, like its y-intercept is given by a coefficient. Okay, if there's this coefficient, it's going to give you this value. This is helpful when you're solving the IXL exercises or anything, because that makes your life easier. Okay, that's all. You don't need to remember this. Okay, the most important thing is this, that it has an asymptote. But here, let's go back to this. What's the most important thing I really want you guys to remember? I'm going to make this bigger for this because this is essential. Before, in the previous video, I said b cannot be negative. B has to be larger than 0. I'm completely sure that somebody listening to that said, wait, but I'm sure I saw some exponential function with a negative sign, something like this. Then why is the teacher saying that b cannot be negative? Okay, this b is not negative. B is 2. What happens here is that we have a coefficient -1. Okay, -1, which is multiplying this 2 raised to the power of x. But b, the base, is not negative. Okay, and at this point, I want to make a very important reminder, which is, and I think it will help make this a little bit clearer, and it's that -2 raised to the power of x is completely different from this. Sorry, I use a parenthesis here and I didn't need to. Minus 2 raised to the power of x is completely different to this. This is not the same. And you guys might be tempted to make these two things equal, but they are not the same. Okay? If I have a function like this, where this minus sign is just a coefficient, that's perfectly legal. I can do this, it's fine. What I am not allowed to do is this. In this case, the base is negative. That's not allowed. That's completely illegal for exponential functions. That doesn't exist as an exponential function because this would make us have complex numbers, and we don't want that. So this is perfectly fine. Okay? Actually, what is going to happen here, that's another thing that you don't need to remember it, but it's helpful when you're solving IXL. And is that if I make this, what is going to happen, actually it's going to be a reflection over the x-axis. Okay? If I do that. Actually, let's go one step further. It would be if I take the function of the exponential decay and I do the same thing, which is making it negative, that's what happens. Okay? It's the same thing. I'm getting the reflection over the x-axis. Okay, once again, you don't need to know that by heart, but it's helpful when you're solving IXL. Okay, it makes your life easier when you have to do this thing about comparing graphs, and that could appear in the exam, I don't know, but it could. So it makes your life easier and it makes it faster. Okay? So let's leave this all cool graphs here and let's go back to this. So this is the coefficient we care about. Okay, I can have this and that can make my um, that can make me have this negative sign here. But remember, this is not making the base negative. It's just a coefficient. Okay, there's another coefficient that can appear for us. Actually, let me make this. But I'm not going to go deep into that because I just want to mention it. Actually, I'm not going to mention it here because it's going to get you guys confused. So let's forget about it. That's the only coefficient you need to care about. I was about to talk about the coefficient in the x here, but let's don't bother with that. Just it can be there. That can be a coefficient in the x here, up here in the exponent, but just I won't make a general case about that in theory because it's going to get you guys confused. So yes, this is the coefficient we care about. Okay, same as in the geometric sequence. And now the other thing that is important for us to know is modifying the shape or modifying something, not the shape, but is modifying something in the exponential function are the translations. Not in the sense of translating a text or a word or something, but translating as a movement. Okay, so it's translation here. We can translate functions. You will go deeper into this concept later, like in next year and 10th grade, 11th grade. But the important thing you need to know here, and it's going to be helpful as well, very helpful for those exercises in IXL and everything, are these two types of translations. The first one is the, sorry, it's a vertical translation. The vertical translation happens when I have something like this. I have b raised to the power of x, and I have here a letter, okay? So let's use an example because I know it's way easier for you guys to sit with an example instead of so many letters. So let's say, for example, this function here, 2 raised to the power of x. I'm going to translate it vertically. Where does this happen? Oh, yeah. Okay. What is this making to my function? What is this doing to my function? What's happening here is that my asymptote is being moved. Okay. So now, actually, I'm going to show the value of this visible. Yeah. Y equals 2. Okay. So what happens here is that my asymptote is moved. Let me get rid of this one. Okay. My asymptote changes. So now instead of having my asymptote, that line that the function never touches, instead of being in the axis, it's at y equals 2. Okay. And same thing if I make this 2 raised to the power of x minus 2. If I do, let's duplicate this, and instead of plus 2 is minus 2. What's happening here is that this doesn't copy all the format and everything. Okay, so now here my asymptote is going to be placed at minus 2, y equals minus 2. So vertical translation means that, look, the shape of my curve is the same. It's the same curve with exponential growth and everything, but it's being moved vertically. It's vertically translated. Okay. Once again, this is going to make your life easier when solving the IXL assignments. I just realized this E has nothing to do with the constant E. Okay. Let's use C here. Okay. For you not to get confused. Ok, b raised to the power of x plus c. Ok, lo repito en castellano por si acaso. Aquí puse una e y no quiero que os confundáis con la constante matemática e de la que os hablé antes. Entonces, por eso acabo de cambiar esta letra en la fórmula, pero bueno. Ok, I don't want you guys to get confused with that. So that's it. That's vertical translation. Vertical translation applies both to, of course, both to exponential growth and to exponential decay, of course. If I take, let me get rid of these functions that we are no longer using. This one, we are no longer using them as well. Okay, this one either. So I have this, and okay, I have this one, I have this one, okay, and it applies to exponential decay as well. Okay, these two functions, both the one which is representing exponential decay or exponential growth, both have the asymptote at the same place. If we are translating vertically, it affects both graphs. It's the same, okay? This translation applies to any kind of exponential function. Okay, and the last thing we're talking about here is the horizontal translation. I'm going to move this here, and horizontal translation happens when we have this. Okay, when I have something added to the x. Okay, so here, up here, I can have, let me erase all of this, get rid of it. So now I'm going to do it again. I have 2 raised to the power of x. And if I have 2 raised to the power of x plus 1, plus 5, let's make it more evident. It's being moving horizontally. Okay, it's moving horizontally. I can do it like this, and it moves to the other side. You remember, it's like when we had this quadratic function that we could move them horizontally, it could be moved up and down and everything. It's a similar concept. Okay, you don't need to remember. I'm not asking that this year, that when it's negative it goes to this side, when it's positive to this side. You will have to learn that later in math. But if you know that, it's easier for you to solve these exercises in IXM. Okay, and I'm going to stop here, and I will continue in another video with the solution to a graphical exercise, a graphing exercise.